Welcome back to Maths with Mrs. J. We've been talking about probability density functions. And in our previous video, we talked about how we can use limits to assist us when we have an unbounded domain. We're going to use that here as well, but we're also going to bring in our knowledge about conditional probability. You might recall from our probability topics and videos that conditional probability, the probability of A given B, is the probability of the intersection of those two events occurring divided by the probability of B. Okay, we have a probability density function. Just so you know what this would look like, 5 over x squared is a hyperbola, and as x is tending towards infinity, it's going to look like this. And what we've actually got here is when x is greater than or equal to 5, we're going to have this situation occurring. It's not going to actually touch the x-axis. And everywhere lower than 5, we've got 0. So we do have a probability distribution function in terms of it being above or at the x-axis. We can actually calculate and prove that that area, the limit of that area, will be 1. We're not asked to do that in this case. We're told that it's a PDF. Okay. For part A, we're asked to find the probability that a student takes less than 12 seconds to complete this puzzle. So probability X less than 12. Okay, now in reality, what we're doing here is we're needing to work out the probability between 5 and 12, or the definite integral between 5 and 12 of this function. This is quite easy to do. Just going to get negative 5 on x, 12 to 5. So we get negative 5 on 12 minus negative 5 on 5, which is 1. So that's 7 on 12. All right, 5 on x squared is 5x to the negative 2. So when you increase the index by 1 and divide by the new index, you get that. All right, now we're asked for the probability that a student takes between 8 and 10 seconds, given that we know the student takes less than 12 seconds. So this is like our event B, less than 12 is our event B. So what the probability will be, so probability between 8 and 10, given that x is less than 12. Well, it's going to be the intersection, oh my gosh, sorry about that, 8 less than x less than 10 intersecting with x less than 12 divided by the probability x less than 12. Well, 8 less than x less than 10, all of that intersects with less than 12, doesn't it? So it's going to be this probability divided by, and we've already worked this one out with 7/12. Let's work this one out. So probability that x is between 8 and 10. Well, it's just like what we did there, but from 10 to down to 8. So we've got 8 to 10 of our 5 on x squared, which is obviously negative 5 on x, 10 to 8. So negative 5 on 10 minus negative 5 on 8, which is negative a half plus 5 on 8 is 1/8. So when we pop it in here, so we're going to get 1/8 divided by 7/12, which comes down to 3 over 14 as your probability. So in this particular case, our intersection of those two events happen to be the entirety of this event. That will sometimes happen. Alrighty, so that's our conditional probability. Remember, our probability density functions must be greater than or equal to 0 for all values of x, and the total area under that curve has to be 1 because your total probabilities add up to 1.